Emma wants to build two fence lines that are parallel to each other, I think. I'm missing some text there. A straight private drive is shown below. So we've got some parallel. She wants these fence lines to be parallel to each other and crossed. She wants this straight private drive to cut through the fence lines, right? So basically we've got parallel lines cut by a transversal, right? So this is a real life situation where there are this application of these parallel line theorems. So we need to identify 3 pairs of angles that she could make congruent in order to ensure that the fences are parallel. So basically remember that corresponding angles have to be congruent if we want the lines to be parallel. So I just need to, it only wants 3 pairs. There's actually 4 pairs of congruent angles, right? Or there's actually plenty of things, but corresponding angles have to be congruent. So if angle 5 and angle 7 are congruent, then that pair right there would make sure that these lines are congruent, are parallel. So that's a way that Emma can make sure that her fences are parallel, is that she could make sure that this angle to the road is the same. Another option would be angle 2 with angle 4, right? Angle 2 congruent to angle 4 would make that happen, right? Be careful, don't say things like 7 and 4, because 7 and 4 are always going to be equal because they're a vertical pair no matter what, and there's nothing about those two being congruent that would force anything. This fence could still go any which way and not be parallel, and these would still be congruent. So don't name vertical pairs here. It's true that they will be congruent, but they're not going to be forced. Them being congruent isn't going to force the parallel lines. It has to be something that relates these to each other. So you can name a couple more corresponding angle pairs. The other thing I want to point out is that if they were alternating exterior, like angle 1 and angle 8, right? Angle 1 and angle 8 are alternating on either sides of the transversal and exterior to the fence. If angle 1 and angle 8 were congruent to each other, the alternating exteriors would also force these two parallel lines to be parallel. And same thing with like interior, alternate interior, angle 6, angle 3. Those two alternating on either side of the transversal but interior to the parallel lines, that would force these to be parallel. So there's actually many different pairs of angles that you could choose to force these to be parallel, and it's your choice, but you just need to make sure you're relating either corresponding, alternating exterior, alternating interior, choosing 3 like that. If Emma found measure of angle 6 and measure of angle 4 equaled 180, could she conclude that the two fences are parallel? So if she's saying that if I take this measure and they added to 180 degrees, could she say they're definitely parallel? And my answer is yes, and here's my reasoning, which is the more important thing. Well, if these two are 180, right? Well, first off, angle 4, measure of angle 4 plus measure of angle 8 does equal 180 degrees, right? So these two are supplementary. They equal 180 degrees because they're linear. So and then if she found that measure of angle 4 plus measure of angle 6, so measure of angle 4 plus measure of angle 6 equals 180, because that's given, right? She found that already. So if these two things are both equal to 180, then we could set them equal to each other, right? We could say measure of angle 4 plus measure of angle 8 equals measure of angle 4 plus measure of angle 6, because they're both equal to 180 degrees, right? Then using our algebra, we could subtract from both sides, subtract the same thing from both sides, so those would cancel. That would mean that measure of angle 8 would be equal to measure of angle 6, right? So here the reason we could do that is subtract both sides, right? So these are the reasons for each step. So we just found that measure of angle 8 and measure of angle 6, if she found that these two, if measure of angle 6 plus measure of angle 4 is 180, then we could also conclude that measure of angle 8 was equal to measure of angle 6, right? And if these two measures are equal, then we have corresponding angles that are equal. And so just like up here, if you can show that those two have equal measure, then you know that they're parallel. That's by the parallel line postulate. So fences are parallel by the parallel line postulate. Now you might have had a little more informal reasoning on that. It might not have needed to be such a long proof, but the general idea is, well, if these two are supplementary, and we know that because they're a linear pair. These two are supplementary because she found that it was given, and that forces these two to be congruent, which means that the lines have to be parallel by the parallel line postulate. So number 2 is just more moving from what you know to what you don't using the theories that you know. So they give us that these two lines, MN is parallel to AF, so we can draw our those two are parallel, right? So we can apply ideas about parallel lines to these. And they give us that angle ABC, right here, is 43 degrees. So now we can just start filling out. So they're asking for specific angles and to provide the reasoning to support your answers, right? So measure of angle EBF. They want to know EBF. So this one right here. Now, this is a little bit complicated because we have this extra little segment that we're not used to seeing. We're used to seeing the parallel lines cut by a transversal. But now you've got this like extra thing in the picture that can sometimes make things hard to see. So if I cover that up, you'll see pretty easily that this is vertical with this because these two lines can be extended, so they both share that along with the vertex, and they're opposite each other. So these are vertical angles, which means this has to be congruent to that. So measure of EBF is 43 degrees because of the vertical angle theorem, right? So reasoning to support my answer. Now they want us to find EBA. So that's like right here. And if you notice, EBA makes a linear pair with this angle right here, right? They're adjacent, sharing the same, they're adjacent, and they make a straight line. So these are a linear pair, which means if I take 180 minus 43 degrees, then that would give me 137 degrees. So this is going to be 137 degrees by the linear pair postulate, right? Now they want me to find DBC. And one thing I forgot to put in here is I forgot to add this bit of given information. FBD is 58 degrees, right? So I know that's 137, 43 and 43, 58. So now I've got this missing angle. And if you notice, I know all the angles in this like round of circles except for this angle, right? And I know that in a circle, they all have to add up to 360, right? So if I just take them all and add them together, 137 plus 43 plus 43 plus 58. I get 281. So all of these are added together, 281. And now I need to just subtract that from 360 to figure out what the missing angle is. So this needs to be 79 degrees because angles in circle add to 360. You could have applied the idea that angles in a straight line add to 180 and then just added 58 and 43 and subtracted from 180, and that's also an option. So your reasoning might have been a little different, and that's fine. Okay, EKM, so now EKN. Now we're getting into jumping across the parallel lines. So we're going to need some of the parallel lines to talk to us about this. EKN, so this one, if you notice, this is this sort of upper angle in this group, and the upper angle in this group would be right here. So K corresponds to B, right? And that is 137 degrees, so we know corresponding angle-wise this has to be 137 because of corresponding angles. So now I'm going to leave this very last one for you, the MKB. So you should be able to figure out what MKB is and tell why. And the last problem on this homework is in this diagram below, you're given that measure of angle 1 is congruent to measure of angle 3, but you're told you want to prove that angle 2 is congruent to angle 3. So a plan for a proof, so you need to prove that. So if you just have a plan for a proof, that's fine. So first off, I'm going to say measure of angle 1 equals measure of angle 3 because it's given, right? Now, what other relationships can I do? Remember, if you want to prove something, you kind of need to know how to leapfrog to start relating things. Well, I know just looking at this measure of angle 1 is congruent to equal to measure of angle 2 because they're vertical, right? Measure of angle 1 equals measure of angle 2 because they're vertical angles, right? So notice I can mark this with the same mark. And now I've already got these in my pictures marked with the same mark. Angle 2 and angle 3 are marked with the same mark because they're both equal to angle 1. Both their measures are equal to angle 1. So already I'm at the point where I can say measure of angle 2 is equal to measure of angle 3 because they're both of their measures are equal to the same angle, right? So this is more of like a substitution step. Or you can say both angles are equal to the same angle. Both measures are congruent to the same angle, right? So however you want to explain that, it's really a pretty short proof. You move from given and then vertical angles, and then if they're both equal to the same angle, both measures, then the measures would have to be equal.